Today we're back out in tortoise habitat, that is the habitat of Testudo grica here in southern Spain. And the reason we're out today is that this is really the turning point in the year when all tortoise activity ceases and they begin to enter a state of estivation or summer inactivity, which will last until the first rains come in mid-September. At which point also, by the way, any of the nests with eggs in them that's been laid during this period, before this period, will hatch. They hatch simultaneously with the rain. So we're out here today with a particular job, and that is to plant a load of data loggers in various microclimates used by tortoises, some slightly above ground, in clumps of esparto grass, which is a really key species for them, but others subsoil, just at the exact positions where tortoises rest throughout the summer, waiting for those rains. Now, interestingly, tortoises do not dig down very deep here. The exact maximum depth does vary a little bit according to the size of the tortoise, but generally speaking, they will go down until there's about 0.5 centimetre to 1 centimetre of soil covering the highest part of the carapace. When you think about it, that's not really very deep. Looking at these substrates closely, it's really quite remarkable that they managed to dig down at all, because many of these areas are incredibly stony and very, very tough. Interestingly, only 10 days ago, we did finally get some extremely heavy rains in this area, and this exact spot was awash. It was flooded. There were torrents of water everywhere. But if we look at it now, it's effectively bone dry. The moisture in the soil here, in the substrate, only lasts for very short periods because the air is very hot, often up to over 30 degrees Celsius, can be as high as 40 degrees Celsius. It's very drying. And also the heat of the sun on the surface is incredibly intense. So if we measure surface temperatures on this substrate during this time of year, and as the year goes further on into July, August, we'll often record surface temperatures of 70 degrees Celsius, which is unbelievably hot. And obviously, combined with the wind, which we get quite a lot of, very dry wind, it has an incredibly drying effect. And that is one of the reasons why the tortoises do bury down. Now, a lot of people mistakenly believe, that they are burrowing down into humid microclimates. Well, no, they're not. These humid microclimates, alleged humid microclimates here, simply do not exist. They exist ephemerally, which means they exist for very short periods during certain conditions. So you will find some moisture in the soil and some moisture under the plants during or shortly after rain, but you won't find it the rest of the time. And what the tortoises are really doing, which is quite different from most people's understanding of this, but by burying down, they are reducing the evaporative losses through the skin and from respiration, because in this habitat, they need to be able to conserve as much moisture within their body as possible. And by burying down, that prevents them from losing critical amounts of moisture. It's very effective, and this is why they do it. Many other desert reptiles do it, not just tortoises, but a lot of desert lizards do it, and there's a lot of studies on those. And they're not being found in humid microclimates, amazing, miraculous, damp places in this incredibly arid habitat. No, what they're doing is exactly what other desert reptiles do, which is they use burying down, burrowing, covering themselves with soil as a means to prevent moisture loss and to conserve energy. That's why they do it, and that is how they do it. Well, this is very typical, and as you can see, it's quite sandy and dry and fairly hard to excavate into, but certainly not beyond a tortoise. They can dig into some pretty impressive stuff. But as we dig down, see how far we can get, you'll notice that it's still incredibly dry. And this is certainly as deep as any nest would go, and it's also about as deep as a fairly large tortoise would go during both estivation or brumation over winter. The depths are pretty much the same, but here we're down now to a depth of about 10 centimetres, a bit more maybe, and you can see exactly what this is like. And remember, this was flooded just 10 days ago, saturated, and there was quite a lot of damage locally because the floods were so intense. But all of that has now evaporated away, and this substrate is absolutely bone dry. So dry that if I put a soil moisture meter in it, we won't even get a reading. It's below the threshold that the meters can record. Let's sample another area. Here's another area, it's slightly looser. Again, very sandy, but a lot of rocks, stones beneath it. So, yeah, that's pretty typical. And also, of course, extremely dry, as deep as you can dig. Another feature of this substrate is that it has a very, very fine clays mixed in with it in certain places, and that literally varies from distances of a few meters apart, but according to the local geology. But quite often it has quite a percentage of soft clay, which when it gets wet sets almost like cement. So here's an example of that. That's very, very hard indeed. We are planting our data loggers today at two separate sites. This site here and a site further inland which is at a little bit higher altitude. And of course you do get temperature differences according to altitude. So lower altitudes inland tend to be very hot, higher altitudes inland tend to be a little bit cooler. But on the coast that cycle can be reversed because of the cooling influence of sea breezes. So every single area does have slightly different climatic properties, and these are in fact the true microclimates that tortoises choose or evolve to live in. So they manage using slightly different strategies and certainly different timings, in that they can be active at one site while inactive at another because of these slight differences in temperature according to altitude and proximity to the coast. For a point of reference today, we're finding relative humidity levels at about 33 to 34%, about 1.5 meters off the ground, and the ambient temperature is around about 28.5 degrees Celsius. So that, of course, is measured 1.5 meters off the ground. And if we retake those measurements with the meter on the ground, we will get somewhat different readings. And that can be interesting. In fact, we did an article on that very subject as to why, when you are studying tortoise habitats, it's very important to get both sets of readings, a general ambient, but then also a tortoise level microclimate measurement, because the two do differ substantially. And down at tortoise level, we're seeing that the relative humidity is dropping rapidly, 26 degrees now, but the ambient air temperature, about half a centimetre above ground level, is rising rapidly, 33.4 now, 33.7,
33.5 again, fluctuating around there, and relative humidity sort of settling down around 26.5 to 27.5, which is quite a big difference, as you will have noted from those readings we got at 1.5 meters above ground level.
Just in the short time that I've been here planting the various temperature and humidity recording probes, it has got quite notably hotter. And that is an important thing, because at this time of year, or just before this time of year, tortoises cease activity earlier and earlier in the day. So in early March or April, they may well be active up until 12 o'clock or 1 p.m. or even a bit afterwards. But as May and then June arrives, their latest activity periods will get earlier and earlier. So they will often only be active very early hours of the morning for a fairly short period, because then it begins to get too hot. So up until about 2 to 3 weeks ago, we could find some tortoises active up until about 10 a.m. But the last tortoise I found active here was around 9 a.m. So that period just reduces and reduces. And eventually, when the temperatures really start to get higher, over about 31, 32, 33 Celsius, all activity will cease entirely, and that is when they will enter that summer estivation period, not to emerge again until the autumn and hopefully the rains. The main triggers for estivation are lack of water, which tortoises need to process nitrogenous wastes, which they do very efficiently in terms of using a uric acid-based mechanism as opposed to an ammonia-based mechanism, such as that used by reptiles where there's a lot more water around, like alligators, aquatic turtles, etc. So they've got a very efficient mechanism, but even with that very efficient mechanism, they still need water from time to time. They can obtain some water at many times of the year from eating the green plants, because that contains fluid. But during summer, where these ground temperatures of 60 or 70 Celsius, air temperatures of 35, 40 degrees Celsius, there is no green vegetation around at all that's edible. So they are deprived of food and water. And that is the main trigger. Now, one reason we know this is because if we observe tortoises that live next to irrigated agricultural areas where they have drip irrigation, consequently there's quite a few weeds still growing, and some water available, in the drip system that they can get at. And also other populations that live next to golf courses, for example, that get irrigated and sprinkled. We find that despite the ground temperatures being very high and the air temperatures being the same, some tortoises in those specific locations will remain active and will not enter a full state of estivation. So by a process of elimination, we can pretty reliably say that it is two things that mainly cause them to enter this state. One, lack of fluid, and two, lack of food. Both tend to go together, but if you provide food and you provide water, then they will often remain active even though the temperatures are incredibly high. Of course, they won't be active during the day very much, if at all, in those conditions, because the temperatures are so high that it would be dangerous for them. Because once temperatures get above about 32, 33, and certainly to 38, those are potentially lethal temperatures for a tortoise. So are ground surface temperatures of 38, 40, 50 degrees. These are the kinds of temperatures that will kill the tortoise quite quickly. But they will be active very, very early in the morning sometimes, or sometimes also later at night, just as dusk is coming along. So they will vary their activity pattern, but they may not enter a complete state of estivation when those essentials are provided. On that same topic, there's another really interesting observation of behaviour, And that is that even if you have tortoises in estivation, and they're very deep in estivation, have been in estivation for several weeks, they are certainly not completely comatose. They are not unaware of things going on around them. So they remain responsive very quickly to physical stimuli, for example. And one example of this is that even though they may well be down in estivation, and you then get a summer thunderstorm, even if it happens to be in the dead of night, in total darkness, 1 or 2 or 3 a.m. in the morning, there's suddenly a torrential downpour. Those tortoises often emerge from estivation for a short period. They come out, they have a drink from the rare fluid laying on the surface overnight. And if it continues raining the next morning, they may be out a little bit in that. But generally speaking, within 24 hours to 48 hours at the most, all of that has gone, it's evaporated, burned off, and they will go back down into estivation again to wait the main rains which prompt them to emerge, which, as we mentioned previously, are usually around the middle of September to October. So that's the cycle. The thing that really initiates it and can interrupt it is water. Downpour, thunderstorm, that will end estivation either temporarily or permanently for a little bit before they start to prepare for brumation over winter. Another really interesting aspect of tortoise behaviour and physiology is what is going on during that estivation process. This is known as a hypometabolic state. It's a condition where the tortoise voluntarily lowers its metabolic rate. Now, some animals can do this by a factor of 10 or 20 times. It's quite remarkable. We find this behaviour in some of the desert arthropods, the desert snails, for example. Tortoises don't go quite as far into that state as, say, a snail would, but they certainly are capable of reducing their metabolic rate by a massive amount so that it is only a fraction of what it normally would be. And this is one of the reasons why they can remain at a good weight, in a good hydration status, buried in a very dry substrate amongst quite hot surrounds for a very long time indeed. The earth and the soil around them, the rocks, that's all protecting them from too much excess evaporation. But at the same time, they have lowered their metabolic rate, so they are producing very little extra waste products, which would place an extreme strain upon the system. Now, they do have a very high tolerance in addition to some of these waste products in the system. And there's a great many other things going on, right down to the cellular level whilst they are in one of these hypometabolic states. And in fact, I'm just putting a list up here so you can see a few of these. There's been quite a lot of studies done on this, and it does get rather technical and rather complex, but it is fundamentally important to understand why and how this happens. Understanding these processes and the behaviours associated with them is critical to comprehending why tortoises behave the way they do in specific environments. And we also need to have some level of understanding of what these environments are truly like. Tortoises are supremely adapted, as are many other desert reptiles, to living in incredibly arid areas. They don't need magic provision of things that don't exist, such as humid microclimates in deserts, to survive. They simply do not require it. They have been designed, in effect, to function very well without any of that in these precise environments. So they have a very, very complex physiology. They have behavioural adaptations that allow them to survive. and they are able to cope with levels of toxins, of chemical changes in the body that many other species, many other animals simply could not survive with. Tortoises are amazing animals, superbly adapted to these incredibly arid environments. These adaptations include very complex biochemical abilities. They include highly adaptive behaviours and a number of other strategies designed to allow them to function perfectly in these incredibly arid desert environments. We hope this brief introduction to estivation in Testudo graeca has been of interest, and that by now you will have a better understanding of why these tortoises do what they do, and also of the things, the triggers that cause them to do this. And in addition, one of the most fascinating areas of how their underlying biology, their physiology, is so finely tuned to living in arid areas that it allows them to do that. We continue to be fascinated by it, we continue to study it, and we're learning more about it all the time. Even after all these years, there's still plenty more to learn. So join us on some future expeditions, virtual expeditions out into the wild, and we will be making some more investigations as the summer ends and hopefully the rains arrive and the hatchlings emerge. And not too long after that, only a couple of months, these tortoises will be back in brumation or hibernation again. So we'll be following the year around and following the behaviours and sharing as much of that with you as we possibly can. Thanks.